Welcome to the Advanced Day, and we are going to look at big data. So we go here, and this will be just an introduction. So we'll give you some links in the end for digging deeper into this. But we hope that you will understand how you can work with big data and find more information. And there are also some links about cluster managers and links. So computations may be important for many, but there is another group, of course, that is working more with big data sets, which require a bit different thinking compared to computing. So, well, it could be computing involved, like, for instance, doing a transformation of big data files. But yeah, the key here is that we are using lots of data that maybe not fit into the available memory, the RAM. So we do have several tools to deal with big data in all the languages here. And we will list some of the tools, but there are, of course, other tools as well available out there. So this is not the complete list, of course. So, for instance, in R, we have something called Arrow that can deal with big arrays. We also have a data.table and big memory. And of course, we have links to this. So there are some instructions, how to install it and what it does and how it works. What it can do. Yes. For Matlab, we have the built-in tall arrays and also distributed arrays. So we can click this one as well to see, and we come to MathWorks' own homepage. And this is included in the parallel computing toolbox, which should be available for all our users on the different clusters. Sweden. Julia has Dagger, which is heavily inspired by Dusk for Python, if you have heard of that. We also have memory mapping and big arrays. So these are packages and tools that you can use. And exactly how you do it, I would let you go into the documentation of each of these tools. Another way is to look at effective storage. And well, we could look here actually. This is how you store the data. So different storage formats. And we can have an overview here. This is different data formats. We have a CSV, for instance, that is very common. So yeah, comma separated variables. So of course it's human readable. It's easy to understand. It's quite tidy. And you can use it for long-term storage and also sharing. But it's not very it's not very space effective. For instance, it's a text base, so it's not binary. And yeah, if you want to read a CSV file, you have to load everything into the memory. You can't choose to look at only one segment of the data file. You have to read everything into the memory. On the other hand, we have some other formats like HDF5 and NetCDF4, which use HDF5 inside it, you could say. It's not human readable, it's binary, but instead it's very space efficient. Also, what is interesting here is that you can, if you want to load something to the memory from this file, you can actually choose to only load a chunk of the data. For instance, climate research, data are quite often stored in CDF files where you have metadata defining time frames, defining the area in the domain, so that is the physical space like X, Y, Z coordinates, and also the variables themselves like temperature, wind, and pressure and such. So you can choose to just load specific data into the memory and for availability to your program. Like only the temperature for 1 week and only over Sweden, for instance. So you might have global data, but you are only interested in the area of Sweden. So then just load that information. So that's one way to work with big data files, but only use parts of it, what you need for the moment. Yes. So that's it. This is about storage. But then we have the memory. So storing the data is an efficient way, but that's only one thing. And then using the data in the program is another, because if you now actually need like 20 gigabytes, you can allocate more RAM if you are on the compute center. Yeah. Yes, one could also think about, is more data in variables created during the run or work? So it's not just loading a file or some data into the memory. You have to think of what your program is doing as well. So what you can do now is allocate many cores or a full node. You do not have to explicitly run threads or other parallelisms. Instead, you get more memory by allocating more cores. So what you do now is that you have more memory, but you can only do that within a core, within a node, basically. So you can't load several nodes to get more memory. That won't help you. So that's one, because on many clusters, one core means a certain number of gigabytes of RAM. And if you ask for 2 cores, you will get the double. And if you ask for 3 cores, you will get the triple. On some clusters, you do not have to request additional CPUs to get additional memory. Instead, you can use the slurv options, --mem or --mem per CPU. So this can be done, and then you can ask for the maximum memory of what is available on that node. So this you can think about. Take some time to find out the answers on the questions below using the table of hardware like that. So here we have a table. Let's see if I can make it a bit bigger. Plus. Oh, so okay, it's still wider than we would like to. So, for instance, at Kebnekaise at HPC Turn, we have 28 cores per compute node. We have some large memory nodes as well, with 72 cores. On the ordinary core nodes, we have 128 gigabytes, but then we have also up to 3 terabytes. But for the normal case with the ordinary nodes, we have 128 per node. But if we divide it by 28, we get the number of gigabytes per core. In this case, it will be about 4.5, I think. Yes, 4.5 gigabytes per core. So that means if you don't need the total 128 here, but maybe about the half, like 64 gigabytes, then you allocate 14, the half over 28. So you can ask yourself, how much memory do I get per core? How much memory do I get with 5 cores, for instance? And yes, you know from before how to allocate several cores. So yeah, good. And if you need more than 128, you have to ask for a big or fat node. So for other centers, Pelle, for instance, we have up to 1 terabyte. Tetalit up to 384 gigabytes. And Dardel up to 2 terabytes. Yes. Yes, and I will not cover so much about the cluster managers, but it's about submitting parts of your simulation to the batch queue in a more interactive manner compared to by using batch scripts. In the future, we may have time to cover this. So, and also, yeah, to be in this this material online. So you may come back in a couple of months, maybe next spring, and you can learn more about these things. Yes. So, yeah, we have one example for Julia in this case, which you may look at if you want to. But otherwise, I am finished, and see you next time.